Okay, sorry about that. Interrupted by the phone. Fantastic, right? So I did go online and I found out it didn't print. The information's there. I don't know why this little graph didn't print for this. Whatever. All right. This is a 30, 60, 90 right triangle. We have patterns and special right triangles. Special right triangles. And this is half of a equilateral triangle. If there was another half there, it would look like this. And this would be 60. And this would be 60. So that makes this 30. 30, 60, 90. Do you guys see that? All right. So based off of the 30, 60, 90, this is wrapping it into the back. What patterns could I use based off of that? Forget this half of the table. What patterns can I use for this? Well, we know that 30, 60, 90 looks like this. I'm going to get a second sheet of paper because this gets a little lengthy. For a 30, 60, 90 triangle, we know that this is half because it was an equilateral triangle, right? So this is half of this. X, 2x. Could I write x and 1/2 x if you want to be difficult? Yes, you could do that if you want to be difficult, but I'm not going to because I don't want to be difficult. Which makes this x times the square root of 3. This was the pattern that we learned in the last section. I might have been a couple sections before, but we just learned this, okay? Now, if we look at this right here, that means that this is 60 and this is 6. Well, we can take this reference right here and we can say that this is this. Do you see what I'm saying? What if this unknown triangle was identical to this triangle? We know they're similar because of the angle-angle theorem, right? They're both 90-degree right triangles. They both have 30, 60, 30, 60. So we can say that they're similar, but what if they were congruent? Then we can say that x root 3 is equal to 6. Now that I said it, I can write it. X root 3 equals 6. Okay? Now, I'm going to do something now, and you wouldn't normally think to do it except because of this. I'm going to break the 6 up into root factors. Okay? Let's start like this. 6 is equal to 2 times 3. Everybody knows that. It's a root 3, I'm going to break up this 3 into roots. 2 doesn't change. I know I want a root 3. What times root 3 gives me 3? Root 3. So this is equal to 6. And I just bring this down. Okay? Well, now I can divide both sides by root 3. What does that do? That crosses off one of my root 3. So now when I say cross off, it doesn't make it 0. 0 would zero out the whole thing. It's multiplication. It makes it 1. 1. So I have 1x is equal to 2 root 3. Like I said, how did I know to do this? Is it intuitive? Do you automatically know how to do this? Is there something deep down inside, deep in your gut that says you need to break a 6 into root factor? No. The only reason I knew to do this is because this side of the equation had a root 3 and I wanted to make it look the same. All right. After this is done, we now know our x. We know this bottom. That's what the question is asking for. Find kj. Kj is equal to 2 root 3. I can write my answer right here. I can say that x root 3 is equal to 6. This shows work right here. Then I would say x root 3 is equal to 2 times 3. Still the same problem. X root 3 is equal to 2 root 3 root 3. There we go. One step away. X is equal to 2 root 3. That is my work. Okay? That's not the answer. What's the question? The question is find kj. So therefore, kj equals 2 root 3. Follow? Now, if it had asked us for what is kh, I'm going to go a step further. kh equals, well, we know that this is x and this is 2x, so what is 2 times this? Well, 2 times 2 is, don't hurt yourselves, 2 times 2 is 4 root 3. Why did I go and do kh in addition to kj? Because you're not always going to be asked that. You might be asked this. You might be given this and be told to find this. You might be given this and be told to find this. Any which way, shape, or form. Now, for the second one, use sine, cosine, or tangent. If we look at these problems here, this is all in reference to this table that you're supposed to complete. So let's talk about sine, cosine, and tangent of the 30, or sine, cosine, and tangent of the 60. Or we can talk about using sine, cosine, and tangent and getting a decimal approximate value. If we look at this, we have, here's our 60, here's our 6. Our reference angle is 60, which means what relationship is my 6? That is my opposite. And we need to find kj. What is kj's reference? Or what is kj in relation to the reference angle? Adjacent. What do we know that uses opposite and adjacent? Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. Well, we don't know anything about hypotenuse, so that leaves us with tangent. Tangent is opposite over adjacent. Now, when I say tangent, it's more than just the word tan or tangent. It's tangent of 60 degrees. We know that. Tangent of 60. That puts us in a very specific ratio, a very specific number. If I go back to this, tangent of 60 degrees is root 3 over 1. So I could do it a couple different ways. Tangent of 60 is equal to 6 over my adjacent, I'll call x. 6 over x. If I do it this way, shortcut just says move the 6 over. Okay, like this. So I'll end up with 6 over tangent 60. That's a 6, I swear. Is equal to x. And you just type that into the calculator and it gives you a nice decimal. Okay. 6 divided by tan 60. Close it. Enter. That's your decimal. 3.46410151615. It's impossible to know what the rest is because the calculator does it for you and it rounds automatically. So you could say that as your answer. But what if they want an exact answer? If you have this table, tangent of 60 is root 3 over 1. Now, I can't stand that they got rid of the over 1, but it's okay. So tangent of 60 is root 3 over 1. Tangent of 60 is root 3 over 1. But tangent of 60 is 6 over x. Tangent of 60 is 6 over x. Tangent of 60 is root 3 over 1. Using, ready for this? What property are we using? The transitive property of equality. That states if this is equal to tan 60 and this is equal to tan 60 and tan 60 is equal to itself, then this must equal this. The transitive property of equality. A is equal to B. B is equal to C. Therefore, A must equal C. Did I have any sort of relationship between A and C here? No. A is equal to B and B is equal to C. Therefore, A must equal C. tan 60 is equal to 6 over x. Tan 60 is equal to root 3 over 1. Therefore, root 3 over 1 must equal 6 over x. So here I would say root 3 over 1 is equal to 6 over x, also known as kj. Well, quite simply, 6 is not equal to root 3, so we have to cross multiply. Root 3, x root 3 is equal to 6 divide by root 3, divide by root 3, and you will end up with x is equal to 2 root 3. Same process, okay? This is exact, this is an approximation, and in all reality, this is probably fine. Unless it says exact, and that's the one you need. Transfer that onto here. Now for this one, find m, we're finding this, and we know the hypotenuse. If this is an equilateral triangle, equilateral faces, equal sides, 8, 8, 8. Well, if this is 8 and this is a perpendicular bisector, that makes this 4 and this 4. 4, 8. But don't we have a real quick rule that says that this is x, this is 2x, and what is this? What is the